This video shows you a quick and easy way to work out the optimal voltage for a particular LED once you've actually measured the LED in a simple Arduino circuit to measure its voltage and current. Recapping quickly, let's just restate that when you measure the current in a circuit, a series circuit like this one here, you can insert the ammeter or multimeter in any part along here. So I could put the ammeter there, or even in between these two components here. It doesn't matter. So let's just say I put my ammeter here in series, of course, and to work out the optimal voltage for my LED, I put the voltmeter function of the multimeter or the voltmeter from this point here to that point there, in between the two components. So there I'm measuring voltage, and from our previous exercises we measured 2.98 volts for the LED at a current of 0.0161 amps. So using Ohm's law again, okay, I'm going to use some subscripts for my symbols. M means measured voltage and current, and O means optimal voltage and current. And when I say optimal, I mean the voltage when the current is at 20 milliamps. It is important to realize that any component in a circuit will maintain its resistance at the same value regardless of the voltage or current going through it. So using that understanding, talking about our LED in particular here, we have this situation here. So the resistance of the LED from the measured situation, using our multimeter to measure the current through the circuit and the voltage across the LED, will be the same as the resistance of the LED under optimal conditions. So using that equation there, we can therefore use our Ohm's law again, R equals V of I. So for this value here, it is based on dividing the voltage, measured voltage, divided by the measured current, and that will equal the optimal voltage divided by the optimal current. Therefore, using some algebra to convert this equation so that this thing here is by itself, we get this equation over here, right, which is the optimal voltage for our LED is equal to the optimal current, which is 20 milliamps, divided by the measured current, which in this case is 16.1 milliamps, multiplied by the measured voltage across the LED, which is 2.98 volts. And we use that formula there. We put the values into the equation as I just said. We get for that particular LED, the white LED, 3.7 volts at 20 milliamps. So that's a formula you need to apply for every time you're dealing with an LED and you don't know what the voltage is for it. So with the blue ones, white ones, green ones, whatever color ones, this is the process, and you need to do that first before you go about designing how many LEDs you're going to fit into your Christmas lights series or string of lights. Without knowing this precisely, you'll end up either not getting the lights work properly, they'll be too dim, or they'll burn out fast, or whatever. It'll just be wrong. So you need to get these done, work this out first, work out the optimal voltages first for all your LED types.